Hi, my name is Stefan Garcia, Math 2401, 4th semester, and the topic is on Chapter 3, and we are going to learn how to check if a set of vectors in R to the power of n, or coordinates of space over real numbers, are linearly independent. To check if a set of vectors are linearly independent, we must look at the vectors here. This is our example here, and these are C1s. The important thing to know to check if a set of vectors are linearly independent is that A is invertible, A has pivot columns, and A cannot be 0 because C1, C2, C3s are always going to be 0 because it is unique. Now we check to see if our vectors are like this in a straight line, 1 1 1 0 1 1 1, and the rest all zeros. If you got this, then it is linearly independent. If you get this though, you see how all the ones are kind of all over the place, then it is not linearly independent. If you're supposed to get this in order to know if this is linearly dependent. Now we do a little problem here. Now to make sure that this problem is linearly independent, we gotta make sure that in the end it ends up like this, with ones and a cross. Now what we want to do is add row 2 plus row 1, which is going to be 0 2 0, and it's going to look like this. And for row 3 and row 1, we're going to subtract, which is going to be 0 1 and 3. It's going to look like this. Since 2 we want it as 1, so what we're going to do is divide it by 2 and we get 1. After that, we want to subtract row 1 and row 2, which is going to be 1 0 and then -1. And then for we want to add row 3 and row 2, which is going to be 0 0 and 3. Since we have row 3 as the only number in row 3, we want to divide 3, and it's going to end up with 1. Then finally, we want to add row 1 and row 3, since this is the only thing that's bothering us. It's going to be 1 0 0, and finally we end up like this in a row, and that's how we know that it's linearly independent. Thank you for watching.